So in this lecture, we're going to be looking at composite functions. Now, a lot of this will tie into how we've used functions in the past. There's just kind of an extra layer to it. So with function composition, what we're doing is we're layering functions. We're plugging one function into another. And with this, we'll have some new notation with this open circle between the two function names. So how you could read this is f composed with g, but what I often use is calling this f of g. So like how we say f of x, so we would have f and then parentheses with our input of x. So with that, we have f of x. Very similar here, it's just now we're saying f of g, so our input is an entire function. So how we would write that is we'd have f of with our parentheses, and then where we had x before, we're plugging in this entire function g of x. So with these layers, it helps to visualize what the inside function is and what the outside function is. So in this case, g of x would be our inside function. So you can see in those two places. And then f would be considered the outside function. So how we're going to simplify these is first, I'm going to focus on the inside function, and I want to simplify the inside function, if possible. And then what we'll do is our last piece is to plug into the outside function. So we kind of work inside out with this, because we could have multiple layers of functions here. It doesn't have to be just two. What you do is focus on the most inside function and simplify and simplify and simplify until you get to the outside of that function. All right, we'll talk about domain more in future videos, but something we'll need to think about with domain is that we have the domain coming from the inside function, and then we'll have this domain of the overall composite function. So composite function is this f of g that we're talking about. Now, you can be given composite functions in either form of what I've listed here. Sometimes they'll use open circle, sometimes they'll have this layered function form. But typically, what we want to get to is this kind of layered form with the parentheses, because that's more of a form we're comfortable with. But this open circle form is a way of kind of using shorthand to denote the same thing, but they're exactly equal to each other. All right, so let's practice some of these. What we have in this example here are two functions. We have this function f of x, which is the quadratic equation, 5x squared plus 3x minus 1. And then we have g of x, which is a linear function of 2x minus 7. So, for this first example here, what we have is f of g of 2. So, how I would write this is we'd have f on the outside, g on the inside, and then this 2 is giving us a value to input. So it's like we're looking at 2 there. So how I would read that is f of g of 2. So, what we want to do is first see that f is on the outside and this g of 2 is on the inside. So what I want to do is basically ignore f for a moment and just focus on that g of 2. And I want to simplify g of 2. So what we're going to do is some side work here. So I'm just going to separate off to the side here and just look at what is g of 2. So my function g tells me to take 2 times the input, minus 7, and in this case we're thinking of an input of positive 2, which is 4 minus 7, which is negative 3. So what I just found there is that g of 2 is exactly equal to negative 3. So what I'm going to do now is go back to my function and make that replacement. Instead of writing g of 2, I'm going to replace that with negative 3. So this is the same thing as writing f of negative 3. So we simplified the inside of the function, And now we can use the outside function. So now we can use f of x, and we're looking at an input of negative 3. So f of x tells me to take 5 times the input squared plus 3 times the input minus 1. And I am going to keep using this kind of structure form that we talked about with functions, because it's going to help when we start plugging in more complicated pieces. When you're plugging in a number, it's a little more straightforward, but we're going to get more complicated with it, so it's better to have this practice now. So what we're going to do is our input is negative 3, so I'm going to plug in negative 3, plug in negative 3. So this is the same thing as 5 times, so negative 3 squared would be a positive 9. Positive 3 times a negative 3 is a negative 9, and then minus 1. This is the same thing as 45 minus 9 minus 1. Should we plug that into a calculator, simplify it down, should end up with 35. This is good practice to recognize is that typically, not necessarily all of the time, but most of the time, when you're plugging in a number to a function, you're typically getting a number out. So even with this whole function composition, when I get to the end here, because I am just plugging in this number 2, I should get this output of a number instead of an expression, which we'll see that come up in future examples. All right, let's look at another example with this. So in this case, I'm taking g of f of 0. So how I can rewrite this is g is the outside function of f of 0. So it's kind of like each time I write parentheses, that's a replacement for the word of, so g of f of 0. All right, so what we're going to do is simplify the inside, so I'm just going to focus on that f of 0, and I'm going to do some side work to find out what f of 0 is equal to. So we're taking 5 times the input squared plus 3 times the input minus 1, and we're inputting a value of 0. So simplifying that down, we'll have 0 plus 0 minus 1, which is negative 1. So what I can do is make this replacement of that notation of f of 0 with the number negative 1. So this is really looking at g of, instead of f of 0, negative 1. So we'll go to our function g, which tells us to take 2 times the input minus 7, and our input is going to be that number negative 1. So this is the same thing as a negative 2 minus 7, which is negative 9. So through all of this work, this function notation of g of f of 0 is equal to negative 9. In fact, we could summarize that at the end. We do all this solving. We could say g of f of 0 is equal to negative 9. That would be kind of a final spot for us to land. All right. So this next one, g of f of x. So g of f of x. So notice this case where our input is a variable. What that tells me is when I get to the end of simplifying here, I'm going to be ending up with an expression. And x is most likely to be in that expression. Sometimes it can cancel out with other values and disappear, but we should end up with an expression at the end here. So in terms of replacing f of x, we're going to use the function that was given to us. We know f of x is exactly equal to this 5x squared plus 3x minus 1. So that's going to be the input to our function here. So this is the same thing as taking g of 5x squared plus 3x minus 1. And this is that case I was talking about where it helps to think of your function as a kind of structure, an outline. So g tells us to take 2 times whatever our input is minus 7. And in this case, the input for our function g is this entire expression, 5x squared plus 3x minus 1. So that's what we're plugging into our function here. And then we're going to simplify. So simplifying, I'm going to distribute 2 into the parentheses. So 2 times 5x squared, 10x squared. 2 times 3x, 6x, 2 times negative 1, negative 2, and then we have that minus 7 at the end. And I'm just going to combine like terms there, so we'll end up with 10x squared plus 6x minus 9. And that's the expression that we end up with for this g of f of x. All right. We can make composition functions with the same function. So how I would write this is f of negative 1. And how we simplify is exactly the same. It's just we'll only be using that 5x squared plus 3x minus 1 in this process here. So simplifying f of negative 1, we're going to do some work on the side here. So f of negative 1, taking 5 times the input squared plus 3 times the input minus 1. And our input is the value of negative 1. So we have 5 times positive 1, 3 times negative 1, and then a minus 1. So 5 minus 3 is 2, minus 1 is positive 1. So I'm going to make this replacement of where I see f of negative 1. That's the same thing as positive 1. So then what I'm really doing is taking f of positive 1. So we're going to take 5 times the input squared plus 3 times the input minus 1. And our input's going to be positive 1 here. So 5 times 1 squared is 5, plus 3 minus 1, so an 8 minus 1 for a value of 7. All right, let's look at some more cases where we're plugging in a variable. So with this one, we're taking f of g of x. And what I'm going to do is replace g of x with our function, the 2x minus 7. So this is the same thing as f of 2x minus 7 for our input. So my function f tells me to take 5 times the input squared plus 3 times the input minus 1. And our input is this expression 2x minus 7. Change the color there so you can see how it's input. 2x minus 7, 2x minus 7. So here we're going to have some work to do, this 2x minus 7 squared. And if it helps to avoid mistakes, think of this as 5 times 2x minus 7 times 2x minus 7, so that you can clearly see that we need to FOIL there. Out here, we're just going to distribute the 3 in, so that's the same thing as plus 6x minus 21, and then we have a minus 1. So what we're going to do is FOIL. So we'll have 2x times 2x, 2x minus 7, and minus 7 times 2x, and negative 7 times negative 7. So I'm going to keep that 5 out front. 2x times 2x is 4x squared. We're going to have this 2x times negative 7, so negative 14x. We're going to have 2 of those, so I'm just going to skip a little step there, that'll be negative 28x. So that's coming from this 2x times negative 7 for negative 14x, and then we'll have negative 7 times 2x for negative 14x again, so combined negative 28x. Negative 7 times negative 7 for a positive 49. And then outside here, I'm just going to combine those like terms, so I have a plus 6x and a negative 22. All right, now I'm going to distribute the 5 in. So I'm just simplifying down here, combining like terms, taking care of many operations. So 5 times 4x squared is 20x squared. 5 times negative 28 with the help of a calculator will be negative 140, and then x. And 5 times positive 49 with the help of a calculator is positive 245. And then we have this plus 6x minus 22. And then I'm just going to look for like terms. So I have this negative 140x plus 6x. I also have this 245 minus 22. So we're going to end up with 20x squared negative 134x, and then 245 minus 22 will be positive 223. So all of that to get this function f of g of x. So that's the function from the composition where f is the outside function and g is the inside function. All right, one more example here. So this one, we're going to take g of x. So replacing the inside function g of x, we're plugging in 2x minus 7. And g tells us to take 2 times the input, minus 7. And here we're inputting the function 2x minus 7. So we're layering the function with itself. I'm going to distribute the 2 in, so that'll be 4x minus 14. And then we have a minus 7 on the outside there. And then combining like terms, 4x minus 21. All right, so that's how we're going to compute values with our composite functions. What we'll do is first change it to that representation with the parentheses, simplify the inside, and then simplify with the outside function.